Hello, today we're going to be talking about two different types of transformations. We're going to be talking about translations and reflections. The first type of transformation is a translation, which just means a slide. So the first thing I'd like you to do on your notes page is go ahead and draw a triangle MNP. If you look on the left here, these are the coordinates of the M, the N, and the P point. So go ahead and graph those. Pause this video, graph, and then go ahead and start your video again. Okay, let's see if you graph these correctly. So point M is at 4, -2, which would be right here. Then we have N, which is at 0, 2. And then we have P, which is at 5, 2. Go ahead and connect the dots with a ruler so that it makes a triangle. I apologize that mine won't be completely straight because I don't have a tool that will make it perfect. Now what we're going to do is we're going to go ahead and draw a new triangle. It says draw and find the new vertices of the translation -5, +3. So what that means is these are kind of like the directions on how you're going to translate this triangle. All of the x coordinates we want to subtract 5 from. Remember, x is the first number and y is the second number. So taking a look at M and P, M was at 4, -2. So we need to take the 4 and subtract 5. That gives us a new vertice of -1. Now, to the y coordinate, since this is a +3, we want to add 3. So the old point M was at -2, and now we want to add 3 to that, and that gives us +1. So our new point M is at -1, +1. Let's go ahead and graph that. Now let's figure out where the new N is going to be. The old point N was at 0, 2. We need to subtract 5 from the x coordinate and add 2 to the y coordinate. So 0 minus 5 is -5. And 2 plus 3 is +5. So our new point N is at -5, +5. Go ahead and graph it. Lastly, we have point P, which originally was at 5, 2. We need to subtract 5 from the x, so 5 minus 5, which is 0. And then we're going to add 3 to the y, so 2 plus 3 is 5. So our new point P is at 0, 5. Go ahead and graph that point, and then use your ruler to connect your dots. And then you should see that you end up with what looks like the exact same triangle as before, except translated or slid up and to the left. Okay, so now let's go ahead and do one more translation. This time we want to do a translation of 2, -2. So all of the x coordinates we're going to add 2, and then all of the y coordinates we're going to subtract 2 from. So starting with this main triangle, again up here towards the top, we want to go ahead and this one right there, we're going to go ahead and add 2 from the x coordinates and subtract 2 from the y coordinates. Why don't you go ahead and pause the video and see if you can get the new points M, N, and P and draw them, and then start the video to check your answers again. Okay, let's see how you did. So our new points, point M would be at 6, -4. Point N would be at 2, 0. And point P would be at 7, 0. Let's go ahead and graph them and see how that worked. We have 6, -4, which is right here. Then we have 2, 0, and 7, 0. And once again, once we connect them, I know mine doesn't look fabulous, but once you connect them, you should see that you clearly have the same triangle again, except slid down and to the right this time. Now there's one more way that you might see translations done, and this is what it looks like. This is when you don't actually have a coordinate grid with a picture, and so what you'll see is you'll see your directions, except they might be written a little bit differently. This time it's almost a little more obvious to take the x coordinate and add 6, and then take the y coordinate and add 3. So looking at this first one, if we add 6 to all of our x coordinates here on problem number 1, we have -2 plus 6, which would be 4. We have -1 plus 6, which is 5, and -4 plus 6, which is 2. The y coordinates, it says we're going to add 3 to. So 1 plus 3, -4 plus 3, and 2 plus 3. So if you were to graph this triangle right here, it would be a translation of the original triangle. Go ahead and pause the video, do numbers 2 and 3, adding and subtracting as it says in the translation directions, and then go ahead and start the video to check your answers. Okay, let's go ahead and see how you did. So for this problem number 2, we have 7, -4. So our new coordinates are going to be 4, 0. For point B, we have to subtract 3. So -3 minus 3 is -6, and 5 plus 4 is 9. Then we have 2 minus 3, which is -1, and -6 plus 4 is -2. Let's go ahead and check number 3. Little more difficult because we have decimals, but you should be using a calculator, or you can use your paper and pencil because you're very good at adding and subtracting decimals. Okay, so for point A, we have 5.5 minus 1.25. That's 4.25. And -2.5 minus 2.25 is -4.75. For point B, 3.25 minus 1.25 is 2, and -5 minus 2.25 is -7.25. And lastly, we have -1.25 minus 1.25, which is -2.5. And then the -4.75 minus the 2.25 is -5. Okay, the second type of transformation we're going to talk about today is the reflection. What I'd like you to do in your notes is go ahead and draw quadrilateral ABCD. So if you notice right here, here are the points for A, B, C, and D. Pause the video, go ahead and draw your quadrilateral with a ruler, and then go ahead and start the video again to check. Okay, here's the quadrilateral. We have -2, 3. Then 0, 5, then 3, 1, and lastly 3, 3. When we connect our dots, which I'm going to do carefully, even though it's hard to do this on the iPad, this is what your shape should pretty much look like. And so now what you're going to do is you're going to reflect this over the x-axis. Remember that this is the x-axis right here. So what we want to do is we want to flip this image over so that it's almost like a mirror, except it's down below. So what we want to look for is we want to say this point right here is 1 up from the x-axis. So what we're going to do is we're going to count 1 down from the x-axis, and that's where our new point's going to go. This point right here is 3 above the x-axis, so we're going to go to the x-axis and count 3 below, and that's where our new point is going to be. This point right here is 5 above, so let's go 5 below. And then we have the last point, which is 3 above, so we're going to go 3 below. Once we connect our dots, you will see Shazam! We have a reflected image of that quadrilateral. Good job. Now, if it had said to reflect over the y-axis, this is your y-axis. So what you would do is you would kind of do the same thing, except instead you're rotating it left and right. So you would count how far each point is from the y-axis, and then you're going to go that many on the opposite side. Now, if you don't have a picture and you need to reflect over the x-axis, what you're going to do is to reflect a shape over the x-axis, multiply all of the y-coordinates by -1. So what that means is, looking here at our points, all of the x's are going to stay the same, all of the x-coordinates. So -2, 0, 3, and 3. All of the y-coordinates we're going to multiply by -1. And what that's going to do is, if you were to draw the quadrilateral and then draw these new coordinates, you would have a reflected image. So 3 times -1 is -3. 5 times -1 is -5. 1 times -1 is -1. And 3 times -1 is -3. Now, if you take a look at these 4 points right here, they should be the exact same points that we just graphed on our coordinate plane. And they are, so great job. If you want to reflect a shape over the y-axis instead, then what you do is you multiply all of the x-coordinates by -1. So pretty much, if you want to reflect over the y-axis, leave all of the y's the same. Make the x's multiplied by -1. So all of the y's would stay the same, 3, 5, 1, and 3. All of the x's we multiply by -1, which pretty much just means we want the opposite. So the opposite of -2 is +2. Opposite of 0 is just 0. Opposite of 3 is -3. And then another 3 is -3. So if we were to go ahead and graph these 4 points, we would see a reflection over the y-axis. This concludes our lesson on translations and reflections. Thanks for watching. Have a great day.